Today we are taking a look at grouping data in Power Query, and honestly, this is a really fun little puzzle for anyone who enjoys working with M code. It might sound straightforward at first, but the dataset, that's where things get interesting. Instead of a clean tidy table, we are dealing with something that looks more like a messy stream of repeating blocks, and our mission is to transform this chaos into a clean, normalized table. There are two things that make this interesting. First, the fields don't always appear in the same order. Second, some fields can appear multiple times, like product. So we need to identify where each form starts and then extract the information from each one. Let's start with the obvious solution. We can use group by on value 1. It's better to keep all the data, so choose all rows. But look at what happens. All form rows become one group, all field rows become another. That's not what we want. We don't want the group by the value of the first column. We want to group locally. Did you know that group by function has an optional argument? This is where GroupKind.Local comes in handy. It lets you group rows based on their position in the table, instead of treating everything as one big global group. Basically, the rule is following. Start a new group whenever we encounter form in the first column, and keep everything after it in that group until the next form. Power Query is still comparing the actual values from the first column, so form field value are still different keys. So we need to tell Power Query what our definition of a group boundary is, and that's where the custom comparer comes in. The hidden fifth argument. We are essentially telling Power Query, look at the current row, and if it's a form, treat it as a new boundary. This expression here is called an anonymous function, also commonly called a lambda function. X and Y are the parameters, inputs to our function, and they should return the result, number from. In plain English, take inputs and return 1 if the value from the first column equals form, otherwise return 0. It means we are giving the grouping logic a simple numeric signal based on whether the current row is a form, and because we are using GroupKind.Local, the order of the rows matters. Now our data is divided correctly. That's exactly the structure we needed. It's time to build some columns. Once the groups are correct, the difficult part is over. Now, instead of returning the entire nested table data, each underscore symbol, we can create the final columns directly. We'll replace data with customer. Here is what we are doing. Inside the current group, we look at the value to column. Then we find the position of customer word, so list position of. But we don't want the word customer, we want the value after it, so we add 1, list position of plus 1. Then we use the position to retrieve the corresponding row, value 2. And we have our customers. The region is even easier. Remember that the first row in every group is form, so we simply take the first row's value 2. 0 in curly braces means the first item in the list. Now the product, which is the tricky one. Product can appear multiple times. We don't want only the first product. So we need to find all positions where value 2 equals product. We will use list positions function, which gives us all the positions. Then list select function keeps only the positions where the value is product. This way we know where exactly every product field is, but we still need the values after those positions. We can get them using list transform function, and basically the same trick with anonymous functions. I know this is probably the hardest expression in the solution, but notice the pattern. Find positions, keep the needed positions, move one row down, and combine the values. Once you see the pattern, it becomes much easier to reuse. We need to just grab the values from the last column right after the positions we've found, and wrap it in the text combine function, adding the comma and a space between them. Finally, amount. Here we have another useful complication. The last column contains both text and numbers, so we can't simply do list sum. Instead, we can try to convert every value to a number with try otherwise expression. Then we can simply sum the result. This can be done in multiple ways, and don't forget to delete the first column. So what did we actually learn? The key idea wasn't the individual fields, it was how to make Power Query understand where a block starts and ends. Once that's in place, the rest is just extraction, and the product case shows a general pattern. Find positions, shift, and collect the results. It's a small trick, but it shows more often than you'd expect when working with messy, semi-structured data. And that's it for today. See ya!